So what does an automotive engineer actually do? Ever wondered what it really takes to get a car from just a sketch, an idea, all the way to the machine you're driving every single day? Well, today, we're going to pull back the curtain and dive deep into the world of automotive engineering. It's this incredible mix of art and science, all about designing, building, and perfecting the very things that move us.
Okay, so let me ask you this. When I say the words automotive engineer, what's the very first thing that pops into your head? Seriously, what do you picture? Is it someone covered in grease, a wrench sticking out of their back pocket? Or maybe it's the total opposite, someone glued to a computer screen lost in these super complex digital designs?
Well, the truth is, it's kind of both, and that's what makes it so cool. Modern automotive engineering is this amazing fusion, right? It's where the digital architect, the person designing on the screen, shakes hands with the hands-on, get-it-done problem solver. You've got this blend of super high-tech stuff with real, tangible, in-your-face applications.
All right, section 1, dreaming in digital, all about CAD. So to really get a handle on what a modern engineer does, we've got to start where every new car begins. And listen, it's not on some greasy factory floor or an assembly line. Nope, it's born as a digital dream. This is where the real magic of what we call computer-aided design kicks in.
So what is CAD? It stands for Computer-Aided Design, and it's the #1 tool in the engineer's digital toolbox. Think of it like the ultimate high-tech version of Legos or a blueprint. It's this specialized software that lets them build super precise 3D digital models of, well, everything. We're talking from a single tiny bolt all the way up to the entire car chassis. You could say it's literally the vehicle's digital DNA. Every single part exists here first.
And you know, this technology didn't just appear overnight. It has evolved like crazy. It actually got its start way back in the 1960s with guys like Pierre Bézier over at Renault. He was one of the pioneers figuring out how to map a car's sleek, complex curves on a computer. Then, fast forward to the 80s, and boom, it's showing up on desktop computers. And today, wow, it's a whole different universe. We're talking advanced 3D modeling, mind-blowing simulations, and even integrating virtual reality. It's wild.
So what does all this digital power actually get you? Well, it's not just about making things faster. It has completely changed the game. Think about it. With CAD, engineers can play around with thousands of different versions of a part virtually. They can tweak the aerodynamics, test out brand new materials, simulate how a part will handle stress, and they can do all of this before a single piece of real metal is ever cut. I mean, the amount of time and money this saves by not having to build tons of physical prototypes is just massive. And even better, it unleashes creativity. It lets them design more complex, more optimized, and truly groundbreaking cars.
But you know, beyond all the tech specs and the efficiency gains, you have to remember there's a real human side to this. One engineer said it perfectly. There's a joyful feeling seeing your designs on the computer come to life. And that's it, right there. It's that amazing feeling of seeing something that was just pixels on a screen become a real, physical thing you can touch. That's the heart of what it means to create.
Okay, section 2, making it real, the testing phase. So you've got this perfect digital design. It looks great on the screen. But what's next? Well, you've got to make sure it actually works in the real world, right? This is where we leave the digital world behind and head out to the proving grounds.
And this is that other side of the job we talked about. This is where the rubber meets the road, literally. Engineers aren't just stuck behind a desk all day. No way. They get their hands dirty. They're out there working shoulder to shoulder with technicians to build, to analyze, and to test every single thing, from the tiniest gear to the entire, fully assembled car.
And when I say test, I mean they put these things through the ringer. The testing is absolutely relentless. They push vehicles to their absolute limits. We're talking durability tests that simulate decades of driving in just a few weeks, insane crash tests for safety. They'll strap components to vibration tables and literally shake them until they break. And they even have these climatic chambers to see how the car holds up in the scorching desert heat or the freezing Arctic cold. It's intense.
So what happens when something goes wrong? Because, let's be real, in engineering, something always goes wrong. That's part of the job. But engineers don't just start guessing. They're like detectives. They have a methodical process. First step, identify the exact fault. What broke? Step 2, they brainstorm every possible thing that could have caused it. Step 3, they pick the most likely cause and implement a fix. And the final most crucial step, they test it and test it and test it again to be absolutely sure that the fix actually worked.
Okay, moving on to section 3, the engineer's hidden skills. So we've seen the digital design side, and we've seen the intense physical testing. But what are the skills that tie all of this together? I'll give you a hint. It's not just about being a genius at math and physics. There's more to it.
Now take a look at this,
because it might actually surprise you. A massive chunk of an engineer's job, like the biggest piece of the pie, is reading. And right behind that, critical thinking. They spend a huge portion of their time just reading and interpreting super complex information so they can make smart decisions. It really is about understanding the why, just as much, if not more, than the how.
Here's a good way to think about it. Engineering is its own language, and technical manuals, those are the textbooks. Engineers have to be totally fluent. They're constantly poring over these incredibly dense documents. We're talking everything from repair manuals and crazy complex wiring diagrams to step-by-step assembly instructions. You can't skim this stuff. It takes intense focus to follow these procedures with absolute 100% precision.
And here's a perfect everyday example of that. An engineer might have to look at a label, grab a specific part number, and then match that exact number across multiple different systems, like a digital inventory, a physical manual, and an ordering system. Get one digit wrong, just one tiny mistake, the whole project could grind to a halt. In their world, accuracy isn't just important, it's everything.
All right, final section, your automotive career roadmap. So, you feeling inspired? If everything we've talked about sounds like your kind of thing, then let's break down the roadmap to actually making it happen. This is your guide to getting into the driver's seat of your own career in engineering.
So where do you start? Well, first things first, you've got to get the right degree. That's usually going to be in mechanical or automotive engineering. After that, it's all about getting real, hands-on experience. So think internships and co-op programs. The next major milestone is getting your Fundamentals of Engineering license. That's called the FE. And if you really want to climb the ladder and lead projects and teams, you'll eventually aim for the Professional Engineering License, or PE.
And along that whole journey, you're going to need to build up a whole bunch of different skills. I mean, yeah, of course, problem solving and having a good mechanical aptitude are the foundation. But honestly, things like creativity, being super organized, and being able to communicate really complex ideas in a simple way, those are just as crucial. It's really the whole package that makes a great engineer.
So you see, the job of an automotive engineer is more complex, more creative, and more important now than it has ever been. These are the people who are literally designing the future of how we get around, blending that digital artistry with hard, real-world science. So as we look ahead to the next generation of transportation, the only question left to ask is, what will you build?